Folks, this is video segment 7, and I will be introducing the concept of zones, zone method, and we're going to create the plies using zone method, but also as a laminate, okay? Because it's possible to do a zone and then one by one uh, the plies on it, or is possible to define a laminate on that zone and then let Katia do that for you. The problem that we're doing is right here, a very simple one. Uh, I have basically a strip of composite, but the number of plies on the square section is different from the number of plies on the rectangular section. Okay, so let's go ahead and do this. Again, I want to emphasize that this is not the only way of doing the problem, and it may not even be the most efficient way, but I just want to show you the concept. So let's go to generative shape design. On that face, I will sketch two rectangles. On this one, let's do our first boundary of the zone. So this is going to be 50. And this is going to be 50. Okay, exit. Let's fill that, F-I-L-L, and let me join. And notice that the direction of the arrow is up, so make it down so that the positive side of this surface is downward, which means that when later on it's going to be meshed with the shell element, the normal to the shell, which lies on these surfaces, on the surface, is pointing up, opposite to the direction of the joint. Okay, now uh, on the same plane, XY, once again, I will sketch another rectangle, and this is going to be the 100 by 50 strip. So let me see now. For example, we can make this point. I'm going to make this point, control that point, coincident, okay, and then dimension this to be 100 millimeter. Exit, fillet, join it, and make sure the direction of the arrow is downward. Okay, so we did it. Now we're going to create a coordinate system which is going to be used as our rosette. So here is the axis system. Uh, Automatically it puts it at the global origin, but I'm gonna move that point, put the cursor on origin, box, create a point, and for y I'm going to put minus 30. So it's going to put my coordinate system right there, away from these strips. Okay, that's pretty much it as far. Oops, let me go ahead and save this thing. File, save management, save as, desktop, zones, laminates, ply creation. Okay. Now we are done as far as the generative shape design is concerned. We now move to the composite design module. The first thing we're going to do is to create our composite parameters, add material. I will use Kevlar default material property in Catia database. Kevlar, Kevlar. Okay, so then I'm going to select my rosette, add a rosette, move this thing out of the way. You select that coordinate system that we created, say OK, And if this is bothering you, hide the rosette. Okay. And then I'm going to create a laminates. Now what that means is that I'm going to create a laminate 1, which is 2 layers, laminate 2, which is these 3 layers. Okay, so add a laminate, stacking sequence, material is Kevlar. By the way, if you have your own material property and you can't find it in the database, Catia database, you have to make a new property, and you should watch video segments 2 and 3 and tell you how to do that. And then the first one is 0, is that correct? 0 and 45, good. 0 and 45, and then add another one, Kevlar, 45, add. Now, the alternative would have been down here, okay? In other words, select the thickness law, and don't do the one on the top. Select the thickness law, and then, you know, say, I'm on one of these and one of those, etc. I'm not going to do it like that. Okay, so, okay. If you say it says laminate number 9, because I have created some other ones while this session was open, so don't let it bother you. And another one. So stacking sequence, Kevlar, and let me see now. It's going to be 9000. Okay, so 90, add, 0, add, and another 0, add, and we say OK. So we have created our material, we have created the rosette, and we have created the laminate. This is the stacking sequence that you can see. And then we say OK. By the way, you can always export and import this stuff and make modification in your Excel spreadsheet, which I'm not going to do. Okay, good. Let's move on. Now we're going to create our zones. Okay, so before, when I didn't use zone, I created the plies group and then put the plies in the appropriate group. Here, first we're going to select zone group. So the first one is zone group 1. The surface is that one over there. And I'm going to flip the arrow up, draping direction, and rosette is rosette number 1. Okay, so we have created zone group. Now we can create our zone within that zone group 1. Okay, so I'm going to select the zone here. See that? Zone from in the group 1. For the boundary, for the contour, see that contour? I select this, the what is it called? The sketch of the sketch 1, which was for the square piece. For the laminate, I'm going to select the first one, laminate 9, which is 0, 4, 5. Okay, this means stacking sequence 0, 4, 5. Okay, and then rosette is automatically selected. Okay, then I'm going to do another one, another group, zone group 2. The surface is this rectangular patch. Flip the arrow up. Okay, right, and rosette is rosette 1. We say OK, and select the groups in it. Zone 2, zone 2. For the boundary, I'm going to use this other rectangular sketch, which was sketch 2, I believe. Yeah. And for laminate, I'm going to select the other guy, laminate 10, which was 9000. And rosette is automatically selected. We say OK. Now, first of all, let me save everything. And let's actually see whether it did it for us correctly. Oh, wait a minute. We still don't know. We don't have any plies yet. So let's go ahead and create the plies. You see this? You put the cursor there. See, you put the cursor there. Oh, right here. Plies from zone. Plies from zone. In the plies section, plies from zone. See that icon? Okay, group 1. Okay. Make sure that this box is not is checked, okay? If you don't, you get a warning message. It'll do it for you, but you get a warning message. And then that's pretty much it. Yep. So we say okay, and it's done. Notice that the stacking sequence has been created, plies group 1, okay? And the two plies are in here. Do it again. So plies from zone, group 2, make sure this box is checked, okay? You say okay, and here is plies group 2, the 3. Now, why don't we check something? Let's look at the way these plies are created. So here is a ply exploder, group 1, ply. This is fine, except that the order is not correct, okay? Because don't get the impression that this is wrong, it was done wrong, because there is no order. When you do plies from zone, it Catia follows its own algorithm, and it may redo those that order. So you have to fix that. We will in a minute. And plies group 2, apply. Okay, again, the order is not correct. If you do both of them, of course, apply, we have it. Now, we have to go and fix these. The order is supposed to be, this is supposed to be 0 and this is 45. Look at it. 0 first and then 45. Okay. So we double click on this. You can do it from here. You don't have to go to the tree. For the attribute, this is going to be 0. And this one, double click, it's going to be 45. You have to go fix these two. First, you start with 90 and then 0, 0. So double click on this, 90. Double click on this, 0. That's good. That's the way it's supposed to be, right? These two colors represents the zones. If I hide this, for example, look, if I hide it, the surface will, the actual surface will show up. So, uh, what I can do is, first of all, I can get rid of the whole stacking sequence. Right click, and you go and say delete the exploded surface. And then the zone, I hit the other one, I can hide this one too. There we are, okay? As a matter of fact, what I'm going to do is I'm going to hide the entire stack, and I don't know whether I did it right here, because you see the boundaries are still showing up here, so I'm going to hide the entire stack, okay? And these sketches are there, so let me hide the sketches also. So where are the sketches? Sketch 1, hide it. Sketch 2, hide it, because later on I have access to these edges so that I can put clamps and stuff on it. Okay, good. So now save everything. We're gonna go to advanced meshing tool because I want to get a nice looking mesh. So first I'm gonna mesh this guy with the surface mesher, and this is the surface that I'm gonna mesh. Remember, we flip the direction of the surface, the joint surface, downward, so that this is going to be the direction of the normal to the shell elements. That's okay. So 10 millimeter. Now make sure this is on automatic mesh capture. I already talked about this thing I think in the previous video, but if not, we're going to see it again. Make sure this is on. After I do the problem successfully, I'm going to come and uncheck that. What this thing means is that if when you mesh this square piece, you have nodes on the right side of this line. When you mesh the rectangular piece, you have nodes on the left side, and these nodes are not the same. This particular checkbox says if two nodes are within 1 millimeters of each other, then merge them. Okay, so I'm going to leave it on. Of course, quadratic, parabolic, and dominated quad. Mesh it. It's right there. And exit. Do it with the other one, 10 millimeter, again 1 millimeter automatic mesh capture, mesh it, okay, and exit. Okay, good. Now we can go to analysis and simulation, generative structure analysis. Okay. If I say show me the mesh, right click mesh visualization, notice that the line that we had, the seam was over here. If you put the cursor on these elements, you see whether you put it on the left side or the right side, nodes on the edge are the same. Okay. If I had not done that automatic mesh capture, there would have been different nodes on both sides. So I'm going to do that later on. So deactivate this. Okay, good. Now let's put our restraints and loads. So this end is clamped, and this edge is a what's called line force density is applied on it. In other words, what did I have in the? Let me see now. I had it as 100 Newton per meter. Okay, so let's change that to 100 Newton per meter in the positive direction. Okay, now we have to import the material properties, import composite property right there, right there. First of all, the support is going to be this uh, surface, the square surface, and we're going to do it by zone, and the zone is going to be zone 1, zone group 1. So we have to expand our tree. And expand the composite branch, and it's going to be zone 1, zone group 1. And let me see now, how did we want this thing? Now symmetry, remember symmetry means that you place them symmetrically about this reference plane. But if this is stacked up all the way starting from the bottom to the top, then take the symmetry off. If we discussed this thing in the previous videos, if the plane, if this surface was so that these things were symmetrically placed above it, for example, 45 above that plane, 0 below that plane or surface, etc., then you use symmetry. Otherwise, you stack it in this way on top of that reference surface. Okay, so I'll just leave it like that. In other words, what I will do, I will take away that symmetry. So all stacked up like that, starting from the surface, up, up, okay? And then okay, do another one for this guy by zone, select the zone, zone group 2, okay? And once again, I'm going to take the symmetry off because that's what we agreed on. Okay. Hopefully everything is okay here. So let's go ahead and run. And you can look at the deflection. This is going to be, it looks like it's almost 1 millimeter up. Let me change the rendering here. It goes like that. Okay. And then you can do the same stuff that we did in the earlier video segment. You can look at the different stresses, uh, layer by layer. These are things that were done in videos 2 through, I don't know, 4 or 5 repeatedly. So there's no reason to repeat it here. Okay, now the other thing I want to do, I told you what happens if you actually, let me deactivate this. Let me deactivate that. And I think I alluded to this issue before, but okay, so let's go to the surface mesher, and uncheck this automatic mesh capture. Say okay. It says that, it tells you that, okay, the mesh nodes and things like that are going to be different. So let's find below that and mesh it. Basically, it's redoing the mesh. The other one, uncheck this. Say okay, no problem. Mesh it. say OK, and exit. Okay, now if you want to look at the mesh, activate this mesh, put the cursor there, right-click Mesh Visualization, or activate, and change the rendering so that you can see them better. Okay. If you put the cursor on this line, notice that on this is the seam. This is where the seam was. 194 node 194 on this side for this element, but when you go to the other one, oh, 198, 196. So it looks like uh, let me see for a second. I was under the impression that, let me see for a second. One, two, three, four, five. Uh, what is that? Oh, sorry, I picked the wrong line. There, note 31. This is the line, 50 millimeter away from that edge. So note 31. If you take this element right there, see note 31. But if you go to the other side, because node 152. This is why these two nodes are not the same, and when you try to run it, Catia will bomb out. You see that? Okay, it says metric factorization. Although everything it didn't run, but at least you may want to look at why it happened. So if you say show me the deformation, this is what happened because these two nodes, the nodes on both sides are not the same. Okay, so this other transparency is discussing that, and it says watch out for the duplicate nodes and make sure that the box is checked with meaningful tolerance. If you say tolerance of 20 or 30, then a whole whack of nodes are going to get absorbed to each other. Let's actually try it. Let me go there. Let's go back there. Deactivate this. Let's go here. Activate this. But put down maybe 20 millimeters here. Fine. Let's see now. 20 millimeters. See what happens there? You see what happens? So that tolerance should be meaningful. You can't just put randomly big number there because you may be doing stuff like this. But anyway, let's try this thing, see what happens. Let's see what happens here. See, it did run. However, you see how what an ugly mesh it gives you. Yeah. So all I'm saying is that be careful about this tolerance also. It has to make sense. Good luck.